So, hi everyone. I'm going to talk about Vue.js rendering mechanism. I can't see you at all, but it's okay. The light is very light. So, my name is Ema Zyka, and oh, I need this. Sorry. Okay. Can you help me out? Okay. Do I need a different stick? No, right? Okay. Please, a bit more help. Oh, I don't have one. Is it this one? I don't have one. Okay, I can do it from here. We can continue from here. Should I close this and use this one? Δεν ακούγομαι. Τώρα ακούγομαι. Okay. So, my name is Ema Zyka. I'm a lead front-end software engineer at Camelot Lottery Solutions and co-organizer at the Vue.js Athens meetup. I hope you enjoyed yesterday's meetup and you came to see the talks. So for today, I'm going to talk about the Vue.js rendering mechanism, and in order to do that, I will need to go into some more technical details about some concepts such as the virtual DOM. I hope that you have some basic understanding on that, but I will try to also explain that and hope that makes sense. In general, the virtual DOM is a programming concept, and it's the virtual representation of a UI. And this is kept in memory, and we use that in order to sync it into the real DOM of the browser. This concept was, of course, pioneered by React, and it has been adopted by many frameworks, such as Vue does as well. And it's more of a pattern. There's no specific way of implementing it. Each framework uses its own, let's say, way. The main benefit of it, of course, is that we can manipulate the structure of the document we have and use that virtual DOM in order to inspect and compose anything we want, the UI structures we have in a declarative way, and avoid doing any DOM manipulation work that we would do in the case we didn't have such a feature incorporated in the framework. Now, just a quick example, a typical HTML page, in order to just explain you a bit about the virtual DOM. A typical HTML page would look something like that on the left side, and the document object model would be something like in the right side. So this is the virtual representation of it. It's the tree of describing all the elements and the content of this very simple example. Of course, there are no attributes and any more enhanced information, just for the sake of the example. But in the virtual DOM, in Vue specifically, when we have a template, right now we can see a Vue template and not an HTML static page, we would have something like that. It's just a button, could be anything, of course, a very small component. This one is representing, the virtual DOM represents it by using objects. So we have objects that we can assign all the characteristics we want about the elements that they are included inside the templates, and all those are used in order to be able to manipulate these details and actually, for performance reasons, to mount it into the DOM. For Vue, the render pipeline follows some specific steps. Those are that it gets the template, it compiles the template into render function code, and those functions return the virtual DOM, as the object we see earlier in the previous example. And the virtual DOM gets mounted into the page and actually gets, it actually reaches the DOM. And when there are some changes, of course, the cycle repeats, and the render function runs again, and it goes through the same steps. But let's get into the details of each step. Vue templates are compiled into render functions, as I mentioned, and this can be done either ahead of time via build step or on the fly by the runtime compiler. And that would mean that in the case we had a template as we saw before, this is a static template written as is and defined during compilation time. We can see the button there, and it's not dynamically created, it's just static code that we wrote. Of course, there are dynamic details of this implementation, but the elements itself are statically typed. And Vue templates are compiled into virtual DOM render functions, as we mentioned before, but also Vue can have APIs, has APIs that we can skip this compilation process and create our own render functions and be able to, let's say, do more complex things and take advantage, leverage anything we want by using, let's say, the more features of the JavaScript that we want. And that would happen in the comparison to the previous example by just calling the render function supported by Vue and assign the details we want in order to do that. I think maybe this is just common sense. There are many frameworks that they do that, of course, but these are the two ways, let's say, that we can do, we can intervene with the template compiler. And one more thing that I would like to mention is that, as I mentioned before, the virtual DOM is getting mounted into the real DOM. So Vue, when it runs those render functions, will try to load this virtual DOM that has kept in memory into the actual DOM by creating the DOM nodes, let's say, for the creation call. And when something changes, because there are tracked dependencies that we typically use in our templates and implementations, these are tracked, and the runtime renderer walks through this new virtual DOM tree, is comparing, of course, does the comparison and updates the virtual DOM first with any necessary updates, and this reaches the actual DOM at the end. This is the patching process, and the first time that does that through the creation call is the mounting process. These are the main two processes that Vue has. And, okay, let me go to the next slide. Of course, there are frameworks that they have all these reconciliation algorithms that also Vue does. They take, most of the time, they take assumptions on what has changed, and they try to ensure correctness. Most of the frameworks, they do the diffing without taking many assumptions, but Vue has a different approach. This is somehow criticized, that we need to, let's say, compare everything, every detail of the elements and the tree chains. But Vue has tried to solve this problem by taking a few assumptions in order to introduce performance. So Vue.js, both the compiler and the runtime, allows us to implement compile time optimizations by taking some assumptions, as I mentioned. The compiler statically analyzes the code. It leaves behind some hints about the kind of changes that may happen to the template. And this way, it can take some decisions in order to avoid doing some work that may introduce some efficiency and performance into the rendering part. The three key areas that, let's say, the features of these processes is the static hoisting, which I'm going to showcase in a few slides, the patch flags, and the tree flattening. About the static hoisting, what Vue does is that when there is some static content, which is not changed, as we see in the example, we have the foo bar, which is statically typed, these are things that Vue will consider as that they won't change, that they will never change. So for this, in the generated code in the bundle at the end, I will show you just the source code in a few minutes here. So once we have static content, Vue will try to hoist these elements on top, will not be part of the render function, and they will, this, let's say, performance step that's taken because it's taking this assumption. Another thing is that in the case that there are some elements in a row consecutively and they are static, this is something that Vue will assume that it will never change, of course, but also it will try to change it, keep it in memory as an HTML string. And at the end, on the generated code, it will create, let's say, constant that will keep this string in memory. And of course, again, it won't try to track any changes on that element. One more interesting thing is the patch flags. Of course, I guess many frameworks do that. There are, in such case, where we can see this example, we can see that there are classes binded, some attributes, even some text interpolations. The render function has behind some generated code, as I mentioned before, with some specific numbers that each determine and describe what the update is going to be. So Vue knows that if there is some binding, there is some kind of change going to happen in the value, and for that case, number 2 is the number that describes this use case. And of course, this is called, these numbers are happening through bitwise operations in order to determine what kind of change is going to happen. And they can be combined in many, let's say, if there are many changes, of course, there will be many combinations of numbers. And this is a very performant way of Vue assuming what kind of change it's going to do. And of course, if it's going to actually diff the element, not only just track the dependencies. And for example, in this case, we can see that there is some code left behind that says 64. This is a number which represents that the whole fragment of multiple roots are going to be kept in order in the template. So it understands that the order of the elements won't change, and it can leave this code behind and make the decision later that it won't again make any work on that in order to compare it, do any diffs, update it, etc. And for these kind of numbers, there is a specific file inside the source code of the Vue.js project, the patch flag TypeScript file, which contains all the categories, all the numbers that represent each process and used in the bundle in the source code. One more thing that I would like to mention is about the tree flattening. So the tree flattening, I guess you are maybe familiar with this terminology. Conceptually, when a block is part of the template and has some stable inner structure, the entire template can be, we can avoid, let's say, a few things in this case and have this kind of performance. For example, in this template, we can see that there are some static elements which are tracked and some that they are not. Each block can track, of course, the elements and the descendants and then child elements. And the tree flattening is something that's happening for those that cannot, that they are not needed to be tracked. The result would be that the Vue.js will keep in memory, let's say in the virtual DOM, those elements that need to be tracked, and keep them in some kind of array, and it will iterate those elements, each of these, in order to just update only the ones that it needs to. So it will skip all the other elements. And I think that is all about, yeah, we mentioned that before. And yeah, thank you very much. I hope you find this interesting. Thank you.